Okay, so what I'm going to do is just plot them. We're going to plot the critical points and the values. Well, we found the critical points relatively easily. I didn't write it down here, but it's pretty obvious. If you set f of x equal to 0, that implies that 1 minus x times 1 plus x is 0, which implies that x is plus or minus 1. So those are known as the critical points. And now, in order to get the critical values here, I have to plug in f of 1, for instance. The function is 3x minus x cubed. So this is 3 times 1 minus 1 cubed, which is 2. And f of minus 1, which is 3 times minus 1 minus minus 1 cubed, which is minus 2. And so I can plot the function here. So here's the point negative 1, and here's up here is 2. So this is, whoops, which one is it? Yeah, this is negative 1, so it's down here, I guess. So it's negative 1, negative 2. And then over here, I have the point 1, 2. All right, now what information do I get from, so I've now plotted I claim, very interesting points. What information do I get from this? The answer is I know something very nearby because I've already checked that the thing is coming down from the left and coming back up, and so it must be shaped like this over here. The tangent line is 0. It's going to be level there. And similarly, over here, it's going to do that. So this is what we know so far based on what we've computed. Question?
Yeah. Do critical values also be very critical points rather than the points at which the derivative is undefined? In other words, if there were a sharp point there.
The question is, what happens if there's a sharp corner? And the answer is, calculus it's not called a critical point. It's a something else. And it's a very important point, too. All right? And we will be discussing those kinds of points. They're much more dramatic instances of that. That's part of what we're going to say. But I just want to save that, all right? We will be discussing that. Yeah, question?
How do you know that at the critical point it's concave?
The question that was asked was, how did I know at the critical point that it's concave down over here and concave up over here? The answer is that I actually did not use the second derivative yet. What I used is another piece of information. I used the information that I derived over here, that f prime is positive where f prime is positive and where it's negative. So what I know is that the graph is going down to the left of minus 1. It's going up to the right here. It's going up here, and it's going down there. I did not use the second derivative. I used the first derivative. Okay, but I didn't just use the fact that there was a turning point here. So actually, I was using the fact that it was a turning point. I wasn't using the fact that it had a second derivative, though. Okay, for now. You can also see it by the second derivative as well.